Welcome, everyone. I would like to present to you AI security, like hacking in the 90s. We've got Dan McInerney, lead threat researcher at Project AI, and we've got Chloe Messdaghi, head of threat research, also at Project AI. Let's hear a large round of applause for them.
Good morning and welcome to day 2 of BlueHat, and thank you so much for coming to this talk, and a big thank you to Microsoft for having us. And this is my first time at BlueHat, and I think it's Dan's first time, so thank you. This is awesome. I just want to quickly let you know, check under your seat. There's something for you. It's right underneath the seat. Go ahead, check. I'm just kidding. Actually, but like Oprah in a certain ways, you all get to walk out with some beautiful limited edition slap bracelets that brings back those wonderful, maybe not wonderful, 90s moments in your life. So congrats, and we also have some of these wonderful bracelets too. So these could all be yours at a price of $0. At the end of this conversation, I'll probably be standing right here, so if you want to get one of these things, come on up. There's plenty for everyone. Now let's get into the real seriousness here. So I myself, my name is Chloe, and we're going to first dive into a few different things. So you may have heard, we work for Project AI. No sales pitches, don't worry. That's all you need to know. So for today, we wanted to make sure that everyone in this room could understand what we're talking about. And for a lot of people, AI ML security is fairly brand new to them, and they may not know too much about it. So we want to make sure that it's inclusive so everyone will have an understanding. So when we dive into the technical aspects here, that everyone can have a better understanding. So if this is your forte, thank you for having patience for the next few minutes. But if this is brand new, I hope I do a solid job explaining things that may seem very confusing at times. So for today, no matter what your job is or your role is, there is something for each one of you. So usually when we think of, new domains in tech, it tends to follow the same arc as you see right here. AI is an entirely new class of applications and underlying infrastructure. And security for new application ecosystems usually go through the same arc as you see on this screen or that screen. But basically it's the same. Knowledge that there's vulnerabilities, followed by the ability to find them, and then adding contextual understanding, and then lastly, not lastly, prioritization, but then hopefully you remediate it in time, people. And as those items increase, of course, we all know in this room that means more threats, and that means thus more defenses. So in every technological transformation domain, you will see probably the same arc as on the screen. So let's go into a little bit on AI ML risks. So examining some of the ways of AI ML creating a risk and security gaps is what we're going to kind of dive into at this time. We all know that AI ML is different. They are completely different. But if you didn't know that, that's okay. This beautiful slide is very self-explanatory. And here's some things to keep in mind when looking at it. So AI is a class of applications, whereas ML is a subset of capabilities. In general, you could think about how it acts, what it does, which determines which category does something belong to, right? So if an application is creating something or doing autonomous actions that involve a range of decisions, that's more likely an AI application. Now, if it's only really optimizing something or continually improving on a single or a few established set of tasks, then you can know right now it's ML. So just as these two things are a little bit different, that might also be a little bit of a difference in the life cycle as well. And the slide does not show it for some reason, but there is a lovely graphic. So let's all try to do our best in visualizing this wonderful graph that is on this screen, okay? It's beautiful. Ah, so pretty. It looks so nice. Okay, now you have to really listen in, okay? So understanding how ML is designed is imperative for the security researcher community. We have to understand in order to understand how to protect or even to pen test on machine learning projects. So with CI/CD pipelines streamlined software development while addressing security concerns at each stage. Data pipelines, as we all probably know in this room, automate data management with a focus on data security. Now, when we get to ML pipelines, it automates machine learning workflows with security spanning data protection, model security, and ongoing model monitoring. So let's go a little bit deeper than that, right? So ML pipeline automates end-to-end process of developing to training and then deploying your machine learning models. And this pipeline includes stages for data pre-processing, model training, evaluation, and deployment. As us in this room, how many of us are security researchers? Please raise your hand. Oh, we're a little shy. It's cool. Let's go. But we have to focus on several aspects here. That includes securing the data used for training, ensuring model clarity, and monitoring model behavior to detect anomalies or potential attacks. So that's why it's really vital for us to understand and mitigate these vulnerabilities within these pipelines in this beautiful graph before you to uphold this overall system and data security. Oh, look, there's a part of it right there at the very bottom. Okay, well, that makes more sense. Oh, it's magic. I'll give you guys a quick sec to look at this. Where's my Hogwarts letter? Darn it. Anyway. Yeah, right? It looks pretty, right? Yeah, okay. Oh, there's another part to it. Okay. The thing is that vulnerabilities in a machine learning pipeline, there's several different unique challenges within it. So management, governance, development, and auditability, as we have seen in other ways in different systems. So let's go into each of these categories. So let's go first, management. So when it comes to management area, you have traditional software development that relies on established processes and automated security checks and CI/CD pipelines. When it comes to ML models, that demands ongoing monitoring, specialized tools, and data security to adapt to evolving threats. Now, when we go into the governance, the next beautiful section on this beautiful chart is that traditional software governance centers on coding standards and compliance frameworks. But when we talk about AI ML governance, that involves ethical data usage, bias prevention, and regulatory compliance, presenting some really distinct challenges. Now we move over to the next category, the development. So traditional software benefits from mature security practices. AI ML introduces novel vulnerabilities like adversarial attacks, data poisoning, and requiring domain-specific expertise. And then the last one, adaptability. As we all know, traditional software provides clear audit trails. However, when it comes to AI ML, these models pose challenges in explaining decisions and creating audit logs, particularly in deep learning models. So overall, the takeaway of this slide is that AI ML software presents really unique security challenges, necessitating adaptation, innovation, and ensuring security, compliance, transparency in the face of evolving threats and regulations. And even though these are the core risk areas anyway that we find in traditional security, this is same applicable to AI ML. When it comes to AI ML vulnerabilities, this can lead to technical risks such as model manipulation, adversarial attacks, or data poisoning. And this does compromise the accuracy and the integrity of AI systems, as you probably know. When it comes to operational, you have operational risk that includes disruptions from model failures or bias issues, leading to incorrect decisions and impacting business operations or safety critical functions. So if we get over to the governance side, the thing about that we always are hearing in the news and everywhere when we have conversations about AI and governance is that there are ethical concerns related to biased models and data misuse. And this is potentially resulting in legal and compliance issues and reputational damage, as you could possibly imagine. And of course, we cannot ever end anything without talking about reputation when there is a breach, right? So AI ML vulnerabilities can harm an organization's reputation if the model fails, or just your normal security breaches that become public, which then intrudes like the trust among our users and our stakeholders. So when it comes to the difference between AI ML and traditional security is that you don't know what's really hidden in your AI ML model. And that's the thing that makes it so much harder to find these vulnerabilities because you can't see what's in the system. And so that makes it more susceptible for exploitation. So we need to understand the difference between the facts and fears. As one of our co-founders says, I believe the BS versus the fertilizer here in this situation. But let's talk about that part. When we think about the fears when it comes to AI, anytime you turn on the news, you probably have seen some images, or maybe you've seen these articles, but people have various fears when it comes to AI about job displacement due to automation, or loss of privacy through data collection, or the potential for bias and discriminatory algorithms. And of course, the rise of super intelligent AI that's going to take out all the humanity here on this planet. Basically, what we're hearing here is that these fears reflect a need for responsible development and regulation for AI technologies. And how many in this room, when you go to any security conferences, keep hearing about prompt injections? It's like the #1 fear. Please raise your hand. Please don't be shy. Right? It is the thing, the center of attention in our industry, which is prompt injections. World's gonna end. But that's a fear. And the reality is that is the least on this lovely graph here. So let's talk about a little bit understanding about AI supply chains, because it is essential at this time. In AI, assets like data sources, models, and tools are key with a small attack surface at the model input level. Model files have security issues, and this allows for command injection. The top risk is the security of tools used by our ML and AI engineers, which often lack testing. And this makes AI departments and teams and initiatives really attracted to target for attackers seeking network access and critical data. And this is why vigilance is addressing these crucial vulnerabilities is kind of up there right now. So I want you to close your eyes, all right? I'm just kidding, you don't have to close your eyes. You don't have to listen to everything people say up here. But let's think about it this way, okay? If my goal as a malicious actor is like, I'm gonna penetrate your organization and gain access to money, right? Do you think I'm gonna spend 3 months on your LLM trying to get it to convince it to give money into my bank account? No, I don't have time for that. No one in this room has time for that. We all work in security, we're all burned out. No, that's not happening. I'm gonna find that shortcut. So I'm gonna spearfish. You're thinking about who is she gonna spearfish? The machine learning engineers. Because the reality is they're most likely the employees to be using the software that gives me access to your internal network through either a public exploit or an easy to find, maybe zero-day exploit as well. So the thing you should know is that your accountants are using software networks that have probably been legally obligated to have been security tested. But the machine learning engineers creating that model that forecasts your profits were probably given full reign to use whatever tools that they wanted. And even though they most likely needed access to things like credit card data and your sensitive financial documents, and you have probably no idea what they even installed. So, how many pen testers are in this room right now? Okay, so the trick here, the big takeaway of this portion is you should consider targeting AI departments and teams at organizations, because it's perhaps the single easiest location to gain a foothold on a network and immediate access to business critical data. So I want us to keep going down these supply chain risks. And to do so, I'm going to introduce Dan over here, and Dan is going to share some of the vulnerabilities that he has found. And yeah, enjoy.
Great. Mic testing. So I'm Dan McInerney. I've been on the red team for about 15 years. I spent the last 3 years building machine learning models, specifically profitable sports prediction models for UFC. And the last couple years, I've been doing full-time AI security research. I've got about 8 CVEs in the AI world to my name, and they did not take very long to find, and I'm going to show you a bunch of them here as real-world examples. All right, so in this last couple years of doing security testing, specifically just for AI, I found some patterns that I don't think a lot of other people have noticed. Source of these patterns is usually going to be because in emerging technologies, you need convenience for the user to increase your adoption, and you need speed of development because obviously it's an emerging technology, it changes quickly. That's the source of these problems. But secondarily, the developers of AI tools I've noticed are a very insular group. There are system administrators that become developers. There's developers that become pen testers. There's network engineers that become IT managers. I'm not seeing that flow between AI and the other IT industries. So what I'm finding is that AI tool engineers are finding a friction point in their workflow. They're fixing it through a tool, and they're sharing it with their friends. But these are not people that are coming from secure coding backgrounds or secure networking backgrounds or anything like that. So there's a lot of holes in the tools that I have found in the AI supply chain and ecosystem. Now, the manifestation of these problems is there's almost no authentication on a lot of these very sensitive tools that hold the keys to the kingdom, the crown jewels. There's way too much access to read-write on the file system. That comes back to convenience. There's insecure network configurations and insecure model storage formats. So the most common vulnerabilities, these are the big four. We've got file include, server-side request forgery, arbitrary file overwrite, and remote code. File include lets you just read anything off the server. So if you spin up an AI tool that is either for sharing AI models or developing AI models, there is a good chance you're going to be able to read any file on that system that you want through a file include vulnerability. Server-side request forgery is interesting because a lot of these tools require that you reach out to an S3 bucket to find the data. And if you just turn that URL from an S3 URL into an internal URL, like an internal network configuration or a local host URL, you can exploit vulnerabilities on the internal network or get sensitive information like a router configuration file and so forth. So that's an interesting one. Arbitrary file overwrite is the big one. I'm finding this all over the place in AI tools. It is just everywhere. And the problem with arbitrary file overwrite is that it often directly leads to remote code execution, because if you can overwrite the bash RC file, you can get a shell, a reverse shell, right back to the hacker. If you can overwrite the SSH keys, then you can just log right into the server. So I'm seeing that all over the place. And finally, remote code execution, which is like the holy grail for us pen testers, because it just makes it so easy to get further network penetration and things like that. But that's, all of these, you will notice, are in the API security realm. And so in my research, I have found that AI security is basically synonymous with API security. I started all of this off trying to look at the adversarial side, like can I get sensitive information out of an LLM, an internally trained LLM? And the answer is yes, but as a hacker of 15 years, is that really the most practical way of going about it? No. Why would I go through the effort when I can just use MLflow and download your model and your data directly through an LFI? It's way easier. So if there's any message I want to get across here, it is that pen testers should be actively hunting AI engineers because they are high privilege users in high privileged sections of the network with access to high privileged data. And they're not necessarily the most security conscious in the organization. So in the realm of API security, this is the most insecure API call I have ever seen. It keeps showing up. Get artifact. So in the ML world, an artifact is essentially just a file output. Like the model is usually considered an artifact in the AI world. So this is the equivalent of saying get file. And now look at this. We've got MLflow, Kubeflow, one that I can't share publicly yet because the maintainer hasn't fixed it, and GitHub. They have all had an API call that says get artifact that has had high to critical vulnerabilities in it. LFI, RCE, XSS, SSRF, all of these are showing up, and this list is a short list. There's a lot more, but I just didn't want to fill the whole screen with a tiny text. So let's get into the real world examples. This is a little bit of an overused XKCD comic because it is so accurate to how realistic hacking works. Now, if this was used in an AI world, it would be like, the first panel would be like, we were able to loot Fort Knox by tricking the Treasury Department's LLM into spitting out the vault combo through a complex mathematical algorithmic attack. And the second panel will be a hacker in his underwear and another hacker sitting across from him, and he says, oh, look, looks like the Treasury Department exposed an MLflow instance, which is just a web server for storing models. And the other guy says, well, did you get the SSH keys? And he's like, yeah, I did. I sprayed them across the network, and now I'm DA. I have access to all their models and all their data and anything else I want. That's AI hacking. That's practical AI hacking. So let's talk about MLflow. This one is near and dear to my heart because it was one of the first CVEs I got in the AI sphere. I was talking, when I first started this little foray into AI security, I was talking to one of my quality machine learning engineer colleagues, Chris King, and I asked him, what would be the most impactful tool? If you had one exploit in one tool, what would give me access to the crown jewels of an AI engineering department? And he's thinking, well, I think that would be MLflow. Software developers have GitHub as their software repository. AI engineers have MLflow as their model repository. It's where you store all the models. It's where you can see the model versions. It often stores data, or it just points out to other data. So it's a beautiful target. It's got 15,000 GitHub stars, 13 million downloads per month. It is ubiquitous in the AI industry. It's everywhere. So I go home. I do a little pip install MLflow start. It's just a little Python package that you can pip install, and then it starts up a web server. And I go to the web server, and first thing I notice is there's no authentication. And I'm thinking, there is no way that this thing is securely coded when it holds the keys to the kingdom, data and models of your entire AI engineering department. So there's got to be something here. I am no longer surprised when there is not authentication on these AI tools, but I was at this point. So I start poking around a little bit. And I found a file path inside of MLflow. But you can see here, there's 1,000 MLflow servers just publicly exposed on the internet. So a 0-day, you have a foothold, a network foothold on 1,000 different organizations using AI. But I found this file path. And as soon as I see a file path, my hacker sense starts tingling. I'm going, this is got to be an LFI. And it turns out it is. So what you're looking at here is on the top section of this slide, I am specifying that I want MLflow to go get the SSH keys. I'm just asking it for the SSH keys. MLflow says, yeah, okay. I'm going to get you those from the SSH folder. And in the second one, I'm asking for the private SSH keys, ID_RSA. And MLflow happily spits it out. So to tell you how this works, a default installation of MLflow with 0 authentication, I can make 3 API calls and get any file on the server. That's SSH keys, that's cloud keys. Because part of the reason MLflow is so cool is because it usually requires, I've noticed in most of the deployments I've seen, it reaches out to an S3 bucket, and it has to get access to that S3 bucket because it's probably a private S3 bucket. So it has to store those cloud credentials somewhere. That's usually going to be stored in the .aws/credentials file. So having access to MLflow gives you high privilege user credential files through the SSH, and usually high privilege access to their cloud environment, as well as access to their models and data already. So this is a fantastic attack that is practical for getting farther into a network that doesn't involve adversarial AI or anything like that. Now, of course, I automated this process and wrote up a little GitHub tool that automatically gets all the SSH keys and cloud keys and interesting files. It's the link there on the bottom. So I wrote a blog post about that. And within a couple weeks, MLflow had several patch bypasses. So MLflow developers, I have a lot of respect for them. They're fast, they care about their product, they respond very quickly, and they fixed it. But in 2 weeks, there was multiple patch bypasses. So I wrote a new blog post. And this one is System Takeover and MLflow Strikes Again and Again. If I wrote this post today, it would say System Takeover and MLflow Strikes Again and Again and Again and Again and Again and Again, with increasing severity so far. So here's an example of a patch bypass. I mean, before, you just specified the file path that you wanted to go get files from. And now you just added period at the beginning of that file path, and you've bypassed the patch. So this is like, this is a pretty average example of the level of security in AI tools, even ubiquitous tools backed by major organizations like MLflow. Which brings me to H2O3. H2O3 is a wonderful, super useful tool. It allows you to not even know anything about AI. You just download a jar file, you run it, it starts up, you import data, you tell it what you want to predict on, and it builds a model for you. Automatically, feature engineering, hyperparameter optimization does everything for you. You don't need to know anything about AI, and you get a nice quality model. I love this tool. But it is also exposed to the entire network by default out of the box. It has no authentication. And I'm like, this looks a lot like the MLflow. So with any kind of system that just imports data, when I'm mapping the application out, the first thing I'm going to do is import some data. So I start typing in a file path in this search bar, and it starts auto-completing my entire file system. I'm like, this is not how this is supposed to work. And notice, you can do this remotely, and it doesn't auto-complete the remote person's file system. It auto-completes the H2O server's file system. So there is CVE number 1. That was just by opening it up. CVE number 2, we've imported the data. Can we read the data we just imported? And the answer is yes, you can. So here is the SSH keys. You can just import them and then read them. That's local file include, no exploit necessary, CVE number 2. CVE number 3, we've imported, we've read the file. Can we export the file? Yes, we can, and there's a handy little overwrite option. And yes, that is a force overwrite. You can brick the system, you can overwrite the bash RC file, you can do whatever you want. So you'll notice by just opening this tool, which is quite popular, it's in a lot of tutorials, I think it's like 7,000 stars on GitHub or something, you can completely take over the system, remotely, out of the box, unauthenticated. Now this brings me to my favorite one, Ray. Ray is exceptionally popular. It has 30,000 GitHub stars. It is used by Amazon, Uber, Shopify, Instacart, all over the place. Now the point of Ray is to cluster a whole bunch of computers and then use that cluster of computers to train a model. Now when I'm at home training my UFC prediction model, it takes 1 minute. I don't need anything more than my laptop. So who needs to use 50 computers to train a model except a large organization trying to handle massive amounts of data? That makes this a super juicy target for hackers. It's exactly the same as MLflow and H2O. You just pip install the package, then you just do Ray start, and it kicks off a web server and an API server, which is interesting. And what's also interesting is it doesn't have authentication, which, again, no longer surprises me. So my buddy Bryce calls me up one day, and he says, hey, I know you got that Hunter bug bounty. That it's a bug bounty for all of our AI tools, open source AI tools. We'll just pay you to find vulnerabilities. You know, it's just a community service. And he's like, hey, can you point me towards maybe a library that you think is going to have some vulnerabilities that I can make some money on? And I'm like, yeah, you know, I saw this Ray tool. It's really popular. No one submitted any vulnerabilities for it. And yet it looks very similar to a couple other tools that I've looked at. And he's like, oh, cool. Well, you want to get started? And it's like 1 o'clock in the afternoon. I'm like, yeah, let's just take a look and poke around together. So we both download it. We boot it up. And within 30 minutes, we had 2 local file includes, a server-side request forgery, and 2 remote anonymous code executions. So we're just giggling away, happy as can be, knowing that we probably just made a lot of money in half an hour by just opening this tool and control Fing for, you know, subprocess.p open and finding out that there's a code execution there. And so we report this. But then a curious thing happens. And Ray, the maintainers, to their credit, responded very quickly, within a day or 2, I think. But they, curiously, marked all of our findings informational. And me and Bryce are looking at each other, and we're like, between the two of us, we have like 30 years of hacking experience. I really don't think these are informational. I mean, we have proof of concepts in the reports. So we go to read the response from Ray. And Ray says, thank you for investigating and working to identify any security concerns within Ray. In this particular case, from the position this query is being run from, the caller would also be able to submit and run arbitrary code for execution. That's a little confusing. And he has a PS saying, hey, we're going to fix this even though it's not an issue. Okay. And Bryce responds back. He's like, what? This doesn't make any sense. Why are these informational? Hi, this particular query can be run from anyone on the network. The proof of concept demonstrates calling this API endpoint anonymously from a remote machine. Please let me know if I can demonstrate this more clearly or answer any additional questions. And so Ray responds, Ray at its core provides blah, blah, blah. Let me just summarize what he just said here, what Ray just said. Point number 1, Ray already allows remote code execution anonymously as a feature. Therefore, all of your vulnerabilities are null and void. Number 2, Ray starts on localhost by default. Therefore, it's secure. And point number 3, you can run Ray off of localhost. You can run it on the network attached interface, so it's exposed everywhere. But no one would do that. That's silly and dangerous, and everybody knows that. So we'll just start with point number 3 there. In the documentation, in at least one place, it recommends you start Ray on 0.0.0.0, the network exposed interface. If you go to GitHub, you will find dozens of issues where people are asking, hey, I want to share Ray with my colleague. How do I do that? And everyone just says, oh, use that command line option that lets you run Ray exposed to the network. But this is all arbitrary. Let's go back to point number 2. Ray is safe because it's running on localhost. That's not true. That's not true at all. There's actually 2 ways of exploiting Ray, even if it's run on localhost alone. Number 1, if you log into the server, if anybody else logs in like as a Linux user onto the server that Ray is running on, they have privilege escalation because you can do remote code execution. So you can run commands as the person that started Ray. And Ray recommends that you run Ray as root to unlock all of its functionality. Therefore, you have a direct privilege escalation into root. But 2 is actually more important because you can do an exploit remotely against Ray. Let me show you how. Now, this is actually one of the first times we are sharing this publicly. This is the largest audience we've shared this with publicly. Ray marked these informational, and therefore they went public. But not many people have visited the specific URL of these reports because it went informational and didn't show up on our bug bounty feed. So enjoy this. This is unpatched still. This is the actual exploit code that Ray says is not a vulnerability. Now you can put this on any domain you want. You send that link over to someone that's running Ray. As soon as they click that link, a file is created on their computer in temp drive-by. It is direct remote code execution through a single link. Now, how is this possible, you might be asking? Because don't modern browsers have CORS, cross-origin resource sharing, to prevent this exact attack? Yes, CORS prevents Google from using your browser to request Facebook information and then returning it. That is true, but CORS has an interesting quirk, and it's called a simple request. Any request that only has a get, post, or head verb and has a limited number of headers, modern browsers will gladly send cross-domain without a pre-flight request, which would normally block it. So that's what we're doing here. We have a simple request bypassing CORS, and we don't care if we can't get the response because we have code execution already. Now, a lot of people are asking me, why does any of this matter? Because these tools are behind our firewalls. We're not publicly exposing them on the internet. I don't care about your firewall. Your firewall means nothing to me. In my 15 years of hacking, I have never hacked a firewall. It's never been necessary. And let me show you why. I'm a hacker trying to get in. I'm going to search LinkedIn for machine learning and your company name. Then I'm going to use the harvester to harvest all the email addresses of your company, which is usually first name at or dot last name at yourcompany.com. Send your machine learning engineers a quick email saying, hey, I see a bug in this issue, this product. Can you take a look at it and forward me to the right person? Or just use a better email than that. I mean, this is just an example. The Ray engineer thinks he's being helpful, and he clicks on it. And now you have internal network access on a high-privileged user with access to high-privileged user credentials, high-privileged data on a nice high-privileged section of the network. So whether you have to assume breach in these cases. I have an infinite amount of tries to get past your firewall. Infinite. And some people are going to be like, oh, our spam filters would catch that email. Go listen to Marcello Salvati's talk at DEF CON this year about spoofing millions of different domains that actively bypass all of the spam filters that we have tested it against, or that he's tested it against. Or I'll just send him a LinkedIn message or a Twitter message or a Facebook message. Like, it's just irrelevant. Like, I'm gonna get past the firewall somehow, and that means I can exploit your AI engineering department through one more step. One more step is all it takes. Now, the vulnerabilities I've shown you today, MLflow, Ray, and H2O, are the tip of the iceberg. We're sitting on a huge amount of 0 days right now through the bug bounty program alone that are one-click exploits in some of the most popular tools in the AI world. So I can't talk about those yet because we have to let some time pass, let the maintainers fix those. But just know that this is the tip of the iceberg. Now, what if you're an internal network pen tester? How do you use this? You might be surprised to learn that Nessus, Metasploit, and Expose, and the rest of these tools do not have fingerprints for any AI tool I have ever looked for. None of them. So what you have to do is actually either use an HTTP screenshot tool to look for HTTP servers, then identify the AI tool by that, or save the Nmap output to a file and Control F for MLflow or whatever. We're working on the tools like Nmap scripts and Nessus plugins to identify all these AI tools. But the fact is, if I'm an internal pen tester and I see a Windows XP box with MS08067 over here, and I see an MLflow box over here, I am sprinting to that MLflow box. That XP box has probably not been touched for 10 years. That MLflow box has high-privileged user credentials, possibly cloud credentials, and high-privileged data access as well. You could end the pen test right there. Say, look, I have all of your data. It's essentially a giant SQL dump of all of their SQL databases in one place. It's a piece of cake. Now, I want to talk about future research real quick. I was brainstorming what would be like the atom bomb of the AI industry if we could find a vulnerability in it. Now, what you're looking at is a very simple script to train a model to detect diabetes on a certain subset of the population. The important part of this is model.predict. That's what all of these models are doing when you feed it data through like an API call, and it makes a prediction. They're calling some form of .predict. PyTorch has this. This is an XGBoost. CatBoost has it. sklearn has this .predict method. What if you went back into the code of XGBoost on GitHub and you found this .predict method? Perhaps it's right here, XGBoost predict from dmatrix. Now this, if you trace this down, it goes into some C code. Now what if you had a buffer overflow or, use after free, some kind of exploit in that C code of the core API of XGBoost or PyTorch or any of these? What have you just done? You have just made every single model ever trained in the history of that library's existence since they had introduced the vulnerability, vulnerable. And there's almost no way of finding out where all your models are stored. Like, there's no search on your network for, hey, I have 16 models on this computer and 16 over here. There's nothing mystical about a model. It's a programmatic object that you serialize to disk. That's it. So you have just made every organization on Earth that has ever used that library and trained a model vulnerable. You can't patch a model. You can't update a model. You have to delete it, retrain it, and redeploy it. What if that model cost millions of dollars to train? What if you had to use Ray and use this giant cluster of computers to train that model? You have to redo it because you are now permanently vulnerable until you delete that model and redeploy it. So that is what I think would be the most interesting bug in the AI sphere. Now, adversarial ML is going to get more important and more interesting as time goes on. I don't think it's ever going to be a more practical attack route than attacking things like the model repositories, things like the libraries used to train the model. I think that's always going to be, from a practical hacker perspective, your largest threat surface when you introduce an AI engineering department into your company. And so if you want to join us, then you can come become a hunter at hunter.com. This is a community service. We do not get paid for this. This is not a service at all that we take clients for or anything. We just take open source libraries and we put them up and we pay you if you find vulnerabilities. Now, in the coming month or two, I think, there is going to be a flood as we get to finally release the earlier vulnerabilities that have been reported here. And there are a huge number of them. And those 3 examples I gave you of vulnerabilities that I found, there's a lot more of those. So we're going to be starting to work towards getting an exploit built for each one of those vulnerabilities, getting a vulnerability scanner plugin for all of these. But pen testers should be on the lookout because the AI industry is about to get flooded with a whole bunch of exploits in extremely popular tools that you probably have never heard of, but exist on your clients' networks that can give you access to incredibly valuable data and credentials. So go ahead and join us over there. It's literally as easy as opening up some of these tools, like you saw with H2O, and you get a CVE. If you want to join the community, if you want help, just hit me up, or Chloe here. You can hit me up on email or on X, Twitter formerly. The bug bounty is hunter.com, and the RAI security community is MLSecOps. That's where we do a lot of discussion about research and things of that nature. And that concludes our presentation on why supply chain is probably the worst part of the security of the AI world. If you guys have any questions, you can come find me. I'll probably be at the Lockpicking Village, and I'll let you know the best answers I have. All right, thank you guys.